Hello everyone, welcome to Repairathon. We have 5 identical Sapphire R9 390 8GB cards to check and repair today. For testing we will be using this here contraption, right? And this old card, whatever it is, I don't know, but it is good if we need to run some memory testing and stuff like that. And I have the T server here on this small USB stick. So multimeter 1, multimeter 2, maybe thermal camera, probably, we'll see. And yeah, I will be cutting a lot because I don't want this to be 5-hour video, given an hour per card, but you know, I don't know, I don't have any plan. I'll just go one by one. Well, I should probably just put numbers on them somehow, maybe some small sticker to differentiate them as we work on them. So that's card number 1 of 5. At this point, I feel I should mention I bought none of these. These are gifts which I'm very thankful for. One of those cards, I've mixed them up, so I don't know which one are coming from where, but or from whom rather. One of those cards is from Carlos from Spain. There is more about cards that Carlos sent on the channel, or it will be, depends which video goes first. And 4 of them are from Peter from North London. Thank you guys very much. This is a huge help for me. And also I should mention, because this is 5 cards, I think this video will be hugely cut. I think the editing will be cutting and more cutting. So I don't know how long it will be at the end, but what I can say is I'll will preserve the some of the diag. For sure I will preserve the fold, of course, and the repair, or how I will approach the repair. So I'll be taking apart all of those one by one, because they are pretty old and I don't know the state of paste in them, so they'll need to come apart anyway. But let's pretend for a minute that we don't want to do it, and let's focus on the measurements. So here's the Astro AI multimeter. Oh, okay. And we go to the horseshoe mode, otherwise known as a resistance mode, and we put black probe anywhere on ground, and we will check 12 volts PCIe first, and we have kilo ohms, which is good, and then the 4th one from the notch to the left. 1, 2, 3, 4. That's 3.3, and we have 418 ohms, which is good. Now we can go and measure the PCI slots, connectors rather. So you can probe on ground, and I don't know, I can't remember which one is ground, which one is not. So this is showing short, so this shouldn't. And we have mega ohms. This is okay, mega ohms. I have good ground, yeah. So I can't see, yeah, there is something here, again short, so that will be ground, that's ground. So I have mega ohms on this connector, which is not normal. So we should have grounds here as well. Yes, we do. So now let's measure here, and we have kilo ohms and rising, and that's mega ohms, this one, which is good because this is probably the sense pin, and this will be 600K. That's ground. Yes. So that's weird. First thing first, that's weird. What do we expect? A blown fuse? Let me take it apart and see. That's the card apart, and yeah, never seen one of those before in my life. So what do we have here? International rectifier. That's probably power management chip. Lots of memory banks. So that's 8 gigs, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so each is responsible for half a meg of frame buffer. There is big chunky pad in here. I'll expect there to be just a just a through hole. No. Oh, so that's for VRM. So this other side of the VRM. And the pad is rather dry, which is to be expected. Look at the amount of fuses here. So there are 4 fuses there, and there's another fuse here for 12 volts. Horseshoe mode. And let's see the fuses first. Good. Good. Not good. This is blown. And this is also blown. Yeah, so that's why we have nothing. We didn't measure anything on this PCIe connector because both of these guys are gone. So why they are gone? Typically this goes to the VRM stuff. So I would expect that one of those guys is blown and we have a short to the core. Let's see that from this side we have 2.3 ohms. Yeah, I'm measuring core at this point. What's my probes? Yeah, this meter is much better. So yeah, I think I'm measuring core. So it's very likely that these two guys saved this card. It's very likely at this point that this card may be repaired. Very weird. What is it? DRMOSes? Okay, I need to look it up. I need to look up what is used here. Now I need to focus on the VRM. That's our goal here. At least we know roughly what's going on with this one at this point. This is weird. What is... There is a S button, Sapphire. Guessing. What it does? Switches BIOS? Overclocks? No idea. First thing first, let's try and guess which of those guys is bad, and I think we will use an alcohol method for this. I had a very good luck with this method, and I'll show you what's what. So here we are under the microscope, and these 4 guys here, so 1, 2, 3 and 4, I suspect to be a memory rail, 1.5 volts. These guys, international rectifier chips. Yeah, they're definitely not MOSFETs. They're some form of DRMOS, and looks like they skipped on the size of them, and the thing is only half the size that it could be. That's of course probably completely unimportant because this board is designed to take different parts. But yeah, any one of those looks suspicious, like, you know, we can look for a melted solder and stuff like this. to be honest, not seeing anything yet, which is also good. It's not a bad thing. That only means that something happened and the fuses prevented further damage. Like last video or couple of videos before, we had a 3080 where there was no fuse on it, and no, it was fused. Oh, can't remember, but anyway, because the rail that failed wasn't fused in any way, the buck converter welded itself to the board. So also on cards that are not fused, you see the damage to the PCB, probably solder everywhere around that melted because of the temperature. And yeah, let's start injecting some voltages, right? One by one we will check the MOSFETs, and remember, when we are now injecting voltages, they go straight through the VRM to the core. So what we don't want, of course, is to send anything more that the core is able to withstand. So I'm thinking 0.6 volts. Let's start with that. That's not a lot, and basically what that means is we may not see the damage, or we may not be able to find the MOSFET, or the MOSFET that, or the DRMOS rather, that is faulty. But let's just see. For this special occasion we have the wire soldered in quote marks to the side of the fuses, and we'll be starting with 0.64 of a volt, and we will go from the very top side first. So remember, we are injecting through the core itself. We have half an ohm, half an amp. So we are injecting 0.3 or thereabouts of a watt right now, which is not much. So, but we are not in constant current mode, we are in constant voltage mode. We can increase probably the wattage if needed. Okay. Okay, let's go to the next one. Okay, let's go to the next one. Add a lot. I want to see if it flows. Kind of flows, but not much. So I'm not very suspicious of this guy compared to this guy. I'm getting an idea how fast all this is happening, you know. So because I need to have a point of reference. They're pretty similar, all of them. Definitely I don't have enough power to check that. Maybe you see something. Hope it's not VMM. Let's add some alcohol quickly. No, they're pretty even. So I'll say, let's see what the thermal camera says about this card. Yeah, and we have definitely something here. See that? So you see how shitty is this camera. I wanted to buy the USB Pro with the lens, but I need to wait. Let me check if I can poke some metal on this point and help myself with what that is. Surprise, surprise. Thermal camera is showing me this guy. I would think that the right one goes to the VCO, not VMem, but I didn't check any schematics or anything, so I may be wrong, and in fact VMem is shut. That would be a very, very bad outcome for this card, because no card can survive that. And take some alcohol. I'm still treating it as I'm shorting this, well, sending this voltage through the VCO, because I don't trust this camera. Can you see anything happening? Because I don't. You know what I think? I think we can try and measure voltages now. So we are looking for 800 millivolts thereabouts. So let's try and measure somewhere, like here. What do we have? Nothing. What do we have here? Nothing. So I don't think that any of these are bad. So I think our thermal camera just lied to us. On the other hand, here I have 250 millivolts, which is, well, a fraction, right? But and here I have 250. So let's see the input. 0, 0. Why I have 250 millivolts in here? That's sus. What can I say? Gate, nothing. Gate, nothing. Yeah, do we have anything here? Oh, we have 250 and 666 millivolts. Nice. Yeah, so it's definitely VCore. So our camera is just lying to us. I need better thermal camera, that's for sure. I'm saving money, but I'm buying jewelry for my wife instead. And the last one is kinda sus. But yeah, I'm calling this guy. It's time to make a call, and I'm calling it now. Let me take it off. So I couldn't find what's really bad, so my camera pointed at the VRAM. Of course I've checked that. First I took the one that I thought is bad, which still may be bad, we will measure them. Then this one, because I thought, yeah, maybe the thermal camera has this, you know, there's some of the cameras, especially the cheap ones, the picture that you see is not exactly aligned with the with whatever the camera is pointing to. So that's why I took this one and then the VRAM. But yeah, none of them were bad. So my intuition was not correct and the thermal camera was incorrect as well. It turns out it was this guy at the very bottom, which didn't look different than this one or this one, its neighbors, under the alcohol test. So that goes to show you, you need for thermal camera, for alcohol method, you need at least some current flowing, because just having half a watt with this thick board, yeah, it's just not viable. So yeah, it is what it is. I took the bad fuses from the board as well. So now is to check the MOSFET is, I think it's just good. The VRAM MOSFET is just good. It will sit there. But I'll check all of them, all three that I took out. Okay, so I've checked the datasheet for this small chip, and the news are not good. Let me switch to the horseshoe mode and then BP mode. So this part here is voltage in, and this is the voltage out. That goes to core, all this. So whatever came here went into the core, straight to core. Oh man. Fortunately, yeah, it got the mark of death. Fortunately, what this means that is VCore sometimes survives that. Depends how fast the fuse reacted. We won't know unless we put the card back together with all the other parts that I unsoldered and try to run it. Otherwise it's just unknown, but it doesn't bode well. Fortunately, I was able to find a card, a donor card for the MOSFET. So there is this one back, this one is back as well, and this MOSFET is back as well for VRAM. And I've replaced the very last one, which is this one. You see the solder blobs, right? And the question always is, do I want it like factory, so like this, or I want it like this with this extra solder? And I'll say I want it like this. The solder blobs are a thermal mass. It can suck some heat from this chip. So, and that is something I've learned from Sorin. If you know Sorin electronics school, he says if you have extra solder, always leave it there for thermals. So I'm leaving it like this. In fact, I will even add more solder, if anything, to each of these pads. They will act like nice heat sinks, like big blobs. But you know, it is what it is. So I've measured, we don't have short on 12 volts anymore. Let's just see if we get any display from this card. Okay, but quickly before I do, this is the fuses now. So they are in parallel, so I've soldered this wire there, right? Because I don't have the fuses. So it is what it is. If it blows, it will be more spectacular this way. So here's a card with a proper calibrated wire, right? And I've connected the HDMI to this monitor. So I'm sharing this monitor between this rig here and the microscope. And there's all the others. And this doesn't always boot anyway, but you know, it's worth a try. So power on. Chip is getting warm. Yeah, in fact it's getting very warm. So let me add this to the mix. Oh yes, we have picture. Yay! You've seen the artifacts. That's normal on this rig. There's something going on with it. That's why it doesn't always boot, but yeah. So I will consider this card repaired. Of course I need fuses, but I'll need to order them because I have none of them. 0 fuses, like completely out. All my donor boards are out of fuses already. it is what it is. But let's go to the card number 2. Let's see what number 2 has to say. So let's start with the PCIe, of course. Horseshoe mode, 12 volts. We have kilo ohms, 3 volts, kilo ohms. Now this. We go maybe ground it there. And this one's good. Don't say this the same thing. No, it's fine. Can we measure? Oh, there is a screw missing. More screws missing there. So we have 4 screws missing already. And yeah, someone was in this before. Let's connect that card to our test rig. So there we have number 2 connected to our monitor, a bootable T server in it as well. Start. Do we get anything? So this boots for a moment. We get no picture out yet. And we are booted with no picture. Right. FF, you see, green light, nothing on the monitor. So I couldn't run any tests on it on the other rig, so I put it in this rig as a secondary card. The primary is the CPU one, and I run GPU Z and see there's some missing info. The device has code 43 or something. Yeah, I think so. So it won't display. I'll try to test it here. I have different sets of tests. Yeah, I can't do anything with it. It's like dead. Won't run any tests. Says no VBIOS as well. Maybe I should open it. One thing just occurred to me. Maybe I'll start with the button in. Maybe that switches to other VBIOS. And I'll look at this. It doesn't report no VBIOS anymore. So I'm like curious. Ha, yes. So one of the BIOSes is corrupted. Jesus Christ, this one works better. So what we can really see here is all that, which just says D0 is our problem. So we have 2 separate issues. Do I have any of the memory? I'll need to check if I have memory for it that I can replace with. And the VBIOS, you know, it's a separate issue. The first observation about this card after opening it is that it's missing all the memory pads. The core doesn't look great. It's missing the pads for these 2 guys as well. And the pads that are still there are not in the great condition at all. So that plus we have one of the BIOS not working and we have D0 nuked. So A0, that's pin 1, A0, A1, B0, B1, C0, C1, D0, right? And this guy is dead. Not the best card I ever seen, but you know, we will work on it. Let me show you. This is the chip that this is D0, this is D1. Take a look at the numbering here, R0C, right? And this is R0C as well. Then you have flux and some solder on the board. And this is C1, this is T2C, and this is C0, is T2C, and that's E0, again, T2C, right? And all the rest of them are T2C. So I think someone replaced this memory, and either the replacement wasn't successful, or the problem is, let me see where this guy goes, in this corner of the GPU. So that will require probably GPU lifting and the memory lifting. I think, well, whatever happens, the memory needs to be lifted, and probably both of those needs to be lifted. And then I don't know if I have the proper memory modules for this. Oh, unfortunately I have none of this stuff, either these or the original ones. I don't have at the moment, so I won't be able to repair this card right now. We have it diagnosed. We know there are these two problems. Just so we are on the same page here, when I said I won't be able to repair it, I will be able to repair it, but I'll need to have the memory bank. So that's number 3 now. I'll need the memory bank. So basically what that means, it's getting it out of some other card. Why am I even opening it? Tell me that. First, let's take some measurements. Horseshoe mode. $12 volts on PCIe connector, kilo ohms, 3.3, 430 ohms. Now connector there, that's fine. That's fine, that sense. Well, is it fine though? Well, yeah, it charges caps. Another one. Yeah, same. This is fine. Yeah, so good that I didn't took it apart completely. Let's test it. Number 3, power on. And we have no response from this card. No fan spin, nothing. So I don't think this card will be recognized at all. But let's see. PC is now behaving very weirdly with this card. Can't post, really. It does post, but then it should do something now, right? And yeah, so the card does something to the motherboard that prevents it from running. So I just opened the card, started measuring things like, you know, these like power rails, stuff like this guy, and look, there's chip missing. You know what that chip is? It's a BIOS chip. It's not on the back plate. How? How come there is no BIOS chip on it? And the pad is missing as well. I think this is the first thing we need to address. This thing. So back to the number 2. Because it's missing pads, it's missing screws, the core doesn't look great, and we have BIOS problem and the memory problem. I need resistors. Now I need a BIOS chip. This one. This becomes my donor card. One of them at least must be. But if needed, I can always reverse it, right? If I found another like with dead core or something, I'll just, swap all these things back. This definitely needs repairing. I can see traces here, right here. That's the rest of the trace that needs to go to the pad. Right. Let's measure some voltage drops. Oh, 1.02, 0.4, 0.4, 0.56, 0.06, 0.4. So that will be ground. Yes. Do we have? Yeah, we have a voltage drop of 0.6 on this one, and this goes there. There's via here. You can barely see it, but it's there. So we need to add a pad right there. Solder the other BIOS on this place before we even move on. Also, this is very near the chip, so I think someone wanted to take the backplate off, because these cards are very hard to take apart. The amount of pads on them is ridiculous, so someone probably stick something in here. Let's see if we are not missing any caps on this side. No, we are not. Quick look around. There's also crystal very near, but yeah, it's fine. So let me handle this problem, solder on the chip, and we will give it another go. There we have it. So basically I've run a tiny copper pad repair thing. You can't even see it, but basically it's here and the leg connects to it, and I hope that is enough. Yeah, it's otherwise soldered on, and let's give it a go. Will it behave any differently though? That's the question, right? Nope. It will not. When booted as the secondary card, it's not there. It's not even recognized. Right. Time to tear it more apart. Looking at it, we have the memory that we need for the other one. What else? I think a lot of heat was involved. Look at the VRAM. Well, VCore stuff. VRAM as well. The board is clearly discolored all around. That's a lot of heat. Okay, let's measure some stuff. $240 ohms, 7 kilo ohms, short on VCO, so again blown fuses, yes, yes. So as I said just a minute ago, a lot of heat on the VRM, so we have a VRM problem. This is how it looks now. So all the VRMs are out. This one is just tacked on for the moment. So basically I found, after removing all the VRMs, I found one of the output capacitors to be bad on the other side of the board. Now I need to solder all this back on. Unfortunately, I also did this because I've mixed up my cards and I started removing RAM from this, and then I was like, oh wait a minute, this is the card I'm working on, this is not a donor board. So good thing I only took 4 out, but I need to rebuild them and put them back on the card anyway. Oh, what a mistake. I just, yeah. And it's even different core. I wanted a completely different card for the RAM removal. I don't know what happened. I'm getting old or something. So the card is missing the BIOS chip right there. And it's missing this capacitor and this capacitor. And I can't remember which one, this small guy or this bigger guy, was shorted. So I'll take another one, well, both of them from the donor board, the BIOS from the donor board, and the VRMs are now soldered. It's not cleaned yet, but there is no more short. The 12 volt PCIe measures about 2 megohms. So yeah, it doesn't look great, but it's good enough. Extra solder there, you know, for cooling. But now I need to address this first. And what I think happened to this card stopped performing super well. Someone wanted to repaste it. And because the backplates are so stuck on these cards, you need to use extensive force to take them out. Someone shoved a screwdriver or something just here, you know, and knocked the BIOS off and the capacitor off, or shorted the capacitor. So yeah, and this one guy is missing as well. So probably some more prying right there. So that is what sometimes happens when users try to upgrade or maintain their own cards. I'm not saying that this is wrong to try to do this, but at least watch a tutorial first or something, and don't use like hard metals on those. If you are struggling to take the backplate off, use like a hair dryer to soften the pads. You know, you can just use hair dryer on the backplate. There are big pads right there, and I think right there for the memory, that are super sticky. You'll soften them, you can take the backplate off. Now to the memory. There's a chips rebuild. Show you. All rebuild. Took me a while, but I'm getting better. I mean faster with that stuff. So let me solder that on. Then we do one more measurement across the thing. Try to inject some voltages maybe. If it's all good, we connect that to our test rig. That's our card number 3 now ready. I took measurements. We have around 100 ohms on memory and I measured all the coils. I've cleaned the PCI teeth pins because they were super dirty, so I give it some clean, and we can now try and connect it to the test rig. I've borrowed from number 2. Just to remind you, number 2 was with the dead D0 and the core that doesn't look great. So I've took out the fuses from it, and I'll be probably borrowing more from it. So number 2 pretty much became, at this point, parts donor, but we may change that later. It depends what happens with the other cards. You know what? I'm connecting it as a primary card, and I connected this to the monitor. I know there was much soldering on it, but can I fit that here? Somehow. Some contact. Right. Okay. I don't think it's shorting anything. So start. So far nothing blow up. Let's wait for this to post. Doesn't look great. Does not want to post really. There it is after much soldering. So to summarize, this guy there was resoldered. These 4 banks were rebolted for no reason. All this V-core was resoldered. And this, I assume PEX, was resoldered. Any of that was really necessary, but it pointed me to the fault. So, well, excluding the memory, that was my mistake. So then on the back side, I've replaced the capacitor. This guy was shorted. I fitted new BIOS chip, and I've repaired one of the tracks under the BIOS chip. Let's see if it starts. I found another missing component. It was the resistor, very small resistor near this buck converter. I think it was a feedback, so pretty important for this to work. So let's go again. That's like, I didn't even count, 4th missing component on this board. So far so good. We are booting. We get artifacts. Very nice artifacts. But it doesn't matter. On this rig, yeah, these artifacts happen with many cards. So yeah, we got it working now. Well, at least displaying. So that's good. We need to test the memory because, all the reball and stuff. And yeah, and the card number 2 was totally sacrificed at this point. As number 3 is ready for testing and is back together, let's go to number 4. I think we will take all the working cards that work on this test rig there and call them to test. Well, they do work, but it's not the end of the story. So we make as many as we can work, and then we'll test them. Every single one of them. Maybe there will be just 2, but hopefully more. Number 4, we have some sticker there. Is that solder? These 2 look suspicious. otherwise in good condition, I think. We have our caps, no major discoloration around the core. Yeah, I'll quickly measure it, and if it's fine, we'll try to run it. Okay, I've measured it. These guys, they measure fine. Those measure fine this time. 3.3 measures fine. As you see, like I said, it was pretty suspicious, this thing. Look, is that just completely melted? And I get open line on this fuse. So this fuse is blown. This is kind of melted, and these legs doesn't look great. So we need to open it. There is no running it like that. I'll try to show you what I see. Sorry, the multimeter is all the way around, but I cannot otherwise have the leads in the place that I need. So black probe on ground. This side of the fuse, there is still nothing, right? This side of the fuse, we get 45 ohms. So that means that the fuse is bad. Yes. And the PCIe 12 volt connectors, the 8 pins, they measure fine. So that tells me that on this specific cards, the 12 volt from PCIe is not used for the VRM for the core. Let's see the memory though. Yeah, it's fine, 130 and climbing. So the memory is fine, the vCore I bet is fine. Let's quickly check. I expect like 2 ohms. Yeah, it is 2 ohms, 2.7 as you can see. And my leads are, yeah, almost nothing. So yeah, the core is healthy, the memory is healthy. That's PEX, which is super healthy as well. This is, I think, like I got 6 volts on the other card, so I don't know what that really is. But I bet the 12 volts is responsible for like only this part of the board. I'm assuming that. We still didn't check any schematics. I don't even know if they are available. But we have one DR MOS here, and this is this guy. And if we check here, which is incoming supply to this guy, is 45 ohms. So we see that this is the 12 volts from the PCIe connector here. We need to get rid of the fuse to even be able to run it. I'll probably change this capacitor as well. There is like 0 ohm resistor here. What this measures? Yeah, this measures again 45.9, which says to me it is good. Yes, it is good. It measures exactly my leads. And so the 12 volts also probably goes to this small guy in there. So this guy may be responsible. This guy may be responsible. That's just 2 guesses for now. There's also a voltage, something that looks like a voltage regulator on the back side. So that will be the third suspect I'll show you. I'm talking about this guy here. So, you know what? Let's measure, in fact, what is going on with this one. What is this? And this seems like ground. Oh, 46 ohms. So again, we see the 12 volt PCIe connector here on this guy. And that's the output. Yeah, whatever it is high resistance, more than 200 ohms. Yeah, and this is ground again. So this is suspect number 3, I think. This is now done. The cap is changed, and I don't have any more of these fuses. So therefore, the one that was there originally was 8 amps. This one is 10 amps. It's fine. but we still can't run this card like this because this will just blow this fuse, because we still have short somewhere. So let's go. Like, this is hard to take out because we have two caps nearby. There's plenty of legs on this guy. It may be blown, but equally something else may be blown. I can't really see anything, but I'll check now under the microscope. Instead of just taking random stuff out, let's think here for a moment, right? So we have some regulators in here and the RMOS. This regulator that is on the other side of the board. We have this guy there, which is pain in the ass. Also we have this guy, which I don't know, maybe that may be a 5 volt, because I know these chips. So if I measure here to leg number 1 is 40 ohms to ground, which indicates the 12 volt in, then the next one is 0 to ground, so the next one is ground, the next one is OL, so more than 200 ohms. This side, all 3, and they all more than 200 ohms. So I don't think this guy is shorted. It still may be between ground and 12 volt, but it otherwise measures fine, right? The same on the back on the other side, or whatever it is, regulator. But here we have the 12 input on this guy, right? We have the 40 ohms, and then we have these caps right there, and I think the voltage should be from this guy to those guys. So if I go this here, I have direct short to 12 volts. So between the input here and this cap here, there is 0. I know that now, but that may be input cap. What about those caps? If I measure them, again, I have straight connection to 12 volts. So that is like this guy. I think this guy just lets 12 volt all the way to the board. So I reckon, even though this will be the hardest to take out, this is what needs to be done. So you see the guy is out of the way now, and let's measure 12 volt. The board is super hot still, but let's measure on here. Oh, we have more than 200 ohms now. Show you. It's half K now. That's ground. Yeah, and now 38 ohms, I show you. 38 ohms. Ugh, can't really see. Let's go there and let's go to the caps. They still measure the 40 ohms. Yeah, so we separated whatever was on the other side of this DRMOS from the 12 volts, which is a kind of the win of the situation, right? We won, we found the fault by just, thinking about it. But whatever is on the other side probably got 12 volt into it. Probably, maybe. We won't know, we need to fit. Again, we will use card number 2 as a donor. We will fit new DRMOS here and see what we get. Is there a point, you ask? Because we know 12 volt was directly shorted to whatever this supplies from here. Well, maybe. Because we still have the entire circuitry here on this card, and I bet this goes to core. right? We can measure how many ohms are originally and compare that to our 30 ohms in here. I'm happy to say that the original card is 56 ohms. So you say, that's half the resistance. Surely something is dead. Well, maybe. Let's do another measurement where the card is the same temperature, is no longer hot from soldering on it, and we get 47. So 10 ohms difference. I'd say this 10 ohms warrants the try. So we solder the DRAM MOS and we see if it works, right? Yes. Don't mind the artifacts. But at this point, I think we have another winner. So card number 4 goes back together for further testing. That leaves us with the last one, number 5. We start, of course, with the same, measuring it from the outside and see what's what. Let's start with the PCIe 3.3, 4th pin. We have 420 ohms or thereabouts, which is fine. 12 volts, nothing. The 12 volt fuse, nothing. The fuse is blown. Oh, these cards are so bad with the TRMOSs. Let's see the resistances on here. PCI. Okay, so that's OL. That's ground. That's 5K climbing. That's now megohms, so that's sense pin. Oh no, it's again it's going down this time, but no short. I don't know. It's behaving erratically. And now it says kilo ohms. See that? I don't know. The first is seems like no connect. Oh, because it's 8 pin. All right. So that's fine. Yeah. So no connect. Kilo ohms climbing. Kilo ohms climbing. Megohms. Good. So here we are fine. But we need to open the card because of course the 12 volt here is. So we already know, right? We've learned something before. We've learned that this 12 volts goes there, probably makes 5 volt rail and stuff. So we may expect our V-core to be good. Oh, while I was taking it apart, I've seen that this screw was on the wrong side. It normally goes right there. These two screws are missing. And this is crooked. So someone was here, definitely. I don't even know if that's a proper screw. Good thing we have the number 2 as a spare, right? So that's the card taken out, or the board rather. We see that the small, like there is a rubber stand here is missing, and we have some smearage, and the paste was changed and there was barely enough of it. Let's measure some stuff. So black probe on ground, this guy, kilo ohms. Then these guys, I'm rather curious, 60 ohms. And on the other side, is ground. This guy there, 60 ohms again. So I suspect 12 volts to be 60 ohms on the fuse. Oh, which it is. So we've already learned something. Last time on number 4 we figured out that the 12 volt blows this fuse when this guy goes out, and the 60 ohm is then fed to the core from this, right? So this allows 12 volt into the core like it is now. So we need to take care of this, which is removing this fuse, removing this guy, taking this guy from the donor, and I found one of those fuses in my parts randomly, so I have one that is exactly this. Also, what I've noticed that the entire shield here, the IO shield, is bent, so we are taking a DR MOS from this guy and the shield and the missing screws as well. The fuse has been changed, the DR MOS has been changed. The card is still kind of, it's warm to the touch, but let's see what we have on 12 now. Oh, it's kilo ohms. So that says to me that we have no longer have a short. Now the question is, does this guy work? Here we are back again. So if everything went smoothly, we shall see the artifacts, and then we should see the yes. And we have a picture, and the core is slowly, very slowly getting warm. Good. Put it back together now. There I have one of the guys running. Have a benchmark right now. The fans on this card are, well, they are kind of worn, but it seems that everything is just fine. Look, I'll check every single one of those like this. They're all here waiting, and I'll report if I found, or whatever I found, right? So that's number 4 done. If you're curious where they go, this is my giveaway box. These cards, ranging from very old Radeon HD to like 550, GTS 240, and I think back there is 750 Ti. There's 550. This is 640, I think, from Gigabyte. All these cards are going to this box to be giveaway. So all of them, I hope, will find new homes, being either repaired or just needed of maintenance. Yeah, not charging anything for that. Anyone can get any of those if they like. Because we're going from 5 to 1, with the exception of number 2 that got parted. This one is the big one for me, because this one lost most of its parts because of my mistake. So the memory was rebuilt and stuff. But yeah, it seems to be working fine as well. And the fans are much quieter on this one. And the last one, number 1. So I resoldered BIOS on this one, and as you can see, this is running on the silent BIOS, 1040 instead of 1080, and 1500 MHz instead of 1800, even though this is selected as the OC BIOS. So what this card needs, the last thing it needs, last piece of work for me before I give them away, or give this one away specifically, is to program the BIOS. So I'll just probably use Windows and do it in Windows. But yeah, it's running fine otherwise. It's just that no matter which BIOS you select is the silent BIOS. So all the cards tested fine, all 4 of them. There is the 4th one. This one or this one, not sure. Got the BIOS update, so it's all fine. Into the box of goodies. I want to thank very much Peter from London for providing 4 Sapphire Nitro, 4 identical ones, and Carlos, I'm not sure the city or town, but Carlos is from Spain. He's also a viewer. He provided a few cards to me, and one of those was Sapphire, that was number 2 in this video, that had a memory channel issue, and this one allowed all those 4 working, providing parts. And thank you very much for watching, guys. I know it was a long video and I'll be probably editing it for like 2 months or so. That's the unfortunate state that I am now, that I don't have really time for editing, and when I do, I'm not good at it at all. So it is what it is, but the video is out now. So thanks again for being here, and I see you on the next one. By the way, these are all the parts that are left over after all this work.